Okay, hello and welcome to this second live session of uh, the course Mechanism and Robot Kinematics. My name is Anirvan Dasgupta. I'm from the Department of Mechanical Engineering at IIT Kharagpur. So let me begin by welcoming you all to this live session. And thank you for joining. If you have any query, if you have any question for which you require some clarification, then you can write on the chat box, and you can also put your questions on that Google spreadsheet which has been shared with you. Okay, let me begin by discussing what we have covered till now. This is your last week of the course. This was for 8 weeks and this is the final week, I suppose. We had one live session around middle of the course, and okay. So since our last live session, we have covered a number of things in this course. We started off our 5th week with velocity analysis using geometric concepts, and in that we used or brought in the concept of relative instantaneous center of rotation between two moving rigid bodies in a plane. And see, the instantaneous center of rotation for a rigid body, uh, we have discussed how to locate the instantaneous center based on the velocities of 2 points. And you have to remember that uh, on a rigid body, if you have 2 points belonging to the rigid body, then their velocities cannot be arbitrary. There is a relation, and that relation stems from the fact that the relative velocity of these 2 points along the line joining the 2 points must be zero, because the body is rigid. And we have used the concept of relative IC to find out uh, the velocity relations between input and output of the mechanism. And to do that, we had to invoke this theorem, the Aronhold-Kennedy theorem, which is a very interesting theorem in its own right. And using that, we have been able to detect all relative ICs of a given mechanism. We have used the circle diagram. And based on the relative IC, we have found out the input-output velocity relation. This was the subject matter of discussion in week 5, velocity analysis, applications of the geometric concepts. And this gives us very nice expressions of the velocity relations in form of the Jacobian. And then we also discussed the singularities of this Jacobian and what it means physically for the mechanism. Singularities of the Jacobian or its inverse would mean that there is either the input or the output has a dead center configuration. So the input or the output has reached some dead center configuration, and it momentarily stops. Say, for example, in the case of the 3R1P mechanism that is used in the IC engine, the top dead center and the bottom dead center, these are two dead center configurations. And in that, the piston comes to a stop. The prismatic joint, the block comes to a momentary stop, and the crank can have any arbitrary angular velocity. So which means you have lost, you have at that specific configuration, you are not able to move the piston by moving the crank. We say that this kind of mechanism, it has gained kind of a degree of freedom, because the input-output relation, as suppose the crank is the input, then it's not able to produce any output. Then the same thing happens at the top dead center. In certain situations, we can have, if for example, a 4R chain, then in one of the dead center configurations, you will not be able to drive the mechanism from the link which has reached a dead center configuration. You will not be able to drive. So you will lose that control. Now, these two situations, they correspond to the Jacobian either going to 0 or the Jacobian inverse going to 0, which means the Jacobian itself is going to infinity. So we have discussed these cases in velocity analysis. Then in week 6, we have looked at an analytical approach for velocity analysis. In that, I had mentioned that so when we go to acceleration analysis, then this IC method will not work, because the relative IC itself has a motion. It is instantaneously at rest. But if you look at two consecutive positions, actually the acceleration will require 3 consecutive positions of the mechanism. IC, the concept of IC depends on two consecutive, two infinitesimally separated consecutive, positions of the configurations of the mechanism. So we shifted to analytical approach of velocity analysis, and I have shown how the Jacobian is derived, how the input-output relations can be found, and given the input velocity configuration and the input velocity, how you can find out the velocity of all other links. Then we, so this was the analytical approach, and this we also carried over to serial manipulator. In week 6, we have looked at the velocity analysis of serial manipulator, and we have looked at two kinds of structures. One is RR and the other is RP. So essentially planar. And then in week 7, we discussed parallel manipulator velocity analysis. Now, in the case of parallel manipulator, as we have seen before, in one of the previous weeks, in the displacement analysis, how it is very easy to solve the inverse kinematics problem, and it is a little hard to solve the direct kinematics problem. But the velocity analysis is, because there is one more thing that I must bring up. The displacement relations or displacement analysis or the input-output relations, they are highly nonlinear, but the velocity relations are linear. Now, in the case of parallel manipulators, we have looked at the velocity analysis by that analytical approach, and we have seen how the input-output relations can be determined, which is linear for a, but the finding the configuration is a nonlinear problem. Now, using this concept of the Jacobian, we have studied the problem of path generation. So if you have the end effector, you want the end effector to move on a certain path, then what we have done is we have determined the velocity vector of the output, and to that corresponding velocity we have determined what should be the joint velocity relations. This is through the Jacobian. For serial manipulator or for the parallel manipulator, we can determine the, so essentially the path generation problem is determination of the joint velocity rates, so joint velocities that will move the end effector on a predestined path with a certain velocity profile. So this was the path generation problem which we have solved using the Jacobian. And the consecutive displacements you can always find by integrating the joint velocities over time. Then that will give you how the joint angles or the joint throws that will vary with time. Of course, at the starting point, you will have to find out the initial joint angles or joint throws so that it starts from the start of a certain desired path. And after that, it's only the velocity that we use to follow the path. Then we moved onto the acceleration analysis, which is one more time derivative of the input-output velocity relations. And we have covered this acceleration analysis in week 7. In week 8, we started with a discussion of force analysis, and in that, so this is the current week. We are discussing rather uh, the analysis of forces, input-output forces. Now, these are not dynamic forces; these are the equilibrating forces. So, if you have to, for example, hold or apply a certain force or a certain torque by a mechanism or a robot, what should be the input joint force or joint torque? This is the key question in this analysis. So force analysis is not about dynamic force analysis, uh, but the equilibrating or static force analysis, which gives us some idea of motor sizing or the prime mover, sizing of the prime mover. So if you want to design a robot for uh, providing a certain amount of force, then what should be the size of the motor that you should use? Now that depends also on the configuration of the robot. So you will have to do some kind of a worst position analysis at which you would like to apply a certain force, and based on that you will design your motors. So that was the question of force analysis. Then we will end this week with some brief introduction to coordinate transformation. This will be for planar manipulators only. We will discuss the homogeneous transformation matrix. Now, so the basic or fundamental discussions on the homogeneous transformation matrix will be discussed, and this can be used in a later course. You can follow up with this. This basic concept will help you in any further course which you take in robotics. Uh, so this homogeneous transformation matrix is a single transformation which deals with both orientation and displacement. So position and orientation. Uh, so the fundamental concepts of rotation matrix, etc., everything is discussed in this, and the homogeneous transformation matrix is derived and used for planar robots to find out the position and orientation. So essentially to uh, determine the position and orientation using the methods of matrices. So matrix-based analysis. So that with that we will complete this course. Now we are so this is the last week, and after this we will have the exam. I would like to give you a brief overview of the question, the final exam paper. Now, this paper has kind of 3 sections. The first section is known as recall. Recall means what you have seen in the videos. So you just recall what was discussed in a certain video on a certain topic. So these are straightforward questions based on the videos that you have gone through. Second, so this will constitute 25% of the question paper. So 1/4 of the question paper will be on recall type, and these are all MCQ type. Then you have assignments. You have, for every week there is an assignment, and so you have, I hope you have been able to solve and get help on the assignments. So this part of the question paper, which is based on the assignment, will be about 50% of the question paper. So half of the question paper is devoted to what you have solved in the assignments. But of course, the data will be different. Finally, we have the remaining 25%, which is based on open questions. Open questions mean they are new questions which you possibly have not seen. And so here you have two kinds of questions, MCQ questions and short answer type. Short answer type means you have to calculate something and put in that number. So please, when you address or answer the short answer type questions, please be mindful of the accuracy of your result that you key in. In some questions, it is mentioned so to what level of accuracy you have to give. Sometimes you have integer answers, so then you have to key in only integers. So these short answer type questions will require some calculation and then typing in your answer. So so this open type question, which is 25% of the question paper, will have both MCQ type as well as short answer type. So that gives you some overview of the question paper for your final exam. Now I would like to see if you have any questions or comments. Okay, so Sarat Sai, Mr. Sarat Sai Kumar has asked one question. What type of questions asked for final exam? If numerical questions asked, will direct substitution in equation, or do we have to derive and calculate? Okay, so thank you for your question, Mr. Sarat. As I have already discussed, let me reiterate. Uh, you will have both MCQ type questions, and most of the questions are MCQ type. Okay, most of the questions are MCQ type. There are a few questions from the open type questions, that means questions which you have possibly not seen before, which are short answer type, where you will have to do some calculation. See, in MCQ also you will have to do calculations and then select the right answer. But in the short answer type, you'll have to calculate and key in the answer. There will be an empty box in which, or empty space, where you'll have to write down the answer, you'll have to type the answer. So these kinds of questions will be there. In numerical questions, typically you'll have to have some formula. I mean, see, for example, the Jacobian. Now, you may or may not remember the Jacobian. It has some complicated structure. We will try to provide in some, if required, we will try to provide the structure. But otherwise, you will have to, for a particular mechanism which you might not have solved, you may have to derive, because you may not remember. You may have solved an assignment, but you may not remember. So you should be able to derive and solve it. And you will have, I believe we'll have time for that, because there are many questions in which the derivations are very simple. So you may have to derive in certain questions. You may have to write down a few steps to finally get the answer. And so what I mean is, it may or may not be direct substitution depending on whether you remember or not. Because sometimes the Jacobian can be uh, quite complex, or some displacement relations. So you may have to find out the displacement relation and then solve. Okay. So I hope I have been able to answer your question. If not, you can write back to us on the forum. So I am tracking this Google Sheet and the chat box. So if you have any question, you can write. If you are a teacher and your students are taking this course, please let us know, give us your feedback. You can give your feedback in the forum as well. And if some question remains unanswered here, then please write to us in the forum and we'll get back to you. So I think we are at the end of our time, and we'll try to wind up from here. So I would like to thank all of you. I would like to also thank the TAs who have worked for this, and the NPTEL staff for making this live session possible. So thank you for attending this meeting.